Hello everyone and welcome to lesson 6-7, equivalent expressions. This lesson is found on page 495. Now we're going to learn some vocabulary that is quite important and it's important for us to use it in the class. You will hear me using words such as coefficient and like terms, and I might ask you how many terms are there, or constant. Okay, let's learn what these are and let's make them part of our math vocabulary. When addition and subtraction signs separate an algebraic expression into parts, each part is called a term. So what they mean is, for example, if I have 4x, I'm going to write it up here, 4x, okay, plus, let's say 7, okay, 4x plus 7. And I ask you, how many terms do you see here? Well, there's this term and this term, okay. This term has its own name, okay. This one has, this is a variable, and you know that it's a variable because it can vary. This x can change when we substitute it with any number that we identify. So it's called a variable. And this one is dependent on this one, because if this one is 2, the entire expression is 8. 4 times 2 is 8. If this one is 3, the entire expression is 12. So this one is kind of codependent on this one. Okay, this one needs this one to identify its entire value. So we call this one a coefficient. This one doesn't change. This one will always be 7. Right? It doesn't have an x, it doesn't have a b, it doesn't have any variable that will change it. So this one's called a constant because it doesn't change. So we have two terms. One coefficient with a variable, okay, and this one is a constant. The numerical factor of a term that contains a variable is called a coefficient. You see that? The entire thing is called a coefficient because they're coefficient on each other. They cooperate, they work with each other. A term without a variable is called a constant. Like terms are terms that contain the same variables, such as x, 2x, and 3x. Remember that x is actually 1x. We just don't write, it's 1x. We just don't write the 1 in front of it. The 1x is x. And here we go. See, we have how many terms? 1, 2, 3. We have 3 terms. And we have 2 like terms. 3x and 1x, which is simply x. So let's label it. Let's label it. Okay, we have, what do we call these? Each one of them is called a, all together, I have 1, 2, and 3 terms, right? And this one and this one are similar because they're both coefficients with the same variable, right? So they are called like terms. And now this one, this number over here, it will not change. It's always going to be 9. These might change depending on the value of n, but this one will not. Because this doesn't change, it remains constant. Please go ahead and copy all 3 of those down. You have 3 terms, 2 like terms, and 1 constant. How does this apply to a real world? Let's look at games. Andrew's mother gave him a computer game and $10 for his birthday. His aunt gave him 2 computer games and $5. Wow, lucky kid. The expression x plus 10 plus 2x plus 5, where x represents the cost of each game, can be used to represent Andrew's birthday gift. So we find the value of his gift. And we know that x, because he only got 1 game at first, right? Up here we see that he got a computer game. So that's represented by x. And plus $10. So that's how much he got from his mother. And then his aunt gave him 2 games, 2 computer games. So that one's represented with 2x, yes, and $5. Okay, and you can see it all there. So what is the coefficient for the term 2x? Well, coefficient, remember we have a variable and a coefficient. The coefficient is 2, yes. How many terms are in the expression x plus 10 plus 2x plus 4? How many terms? 1, 2, 3, 4, right? Simplify expressions with one variable. Simplify. To simplify an algebraic expression, use properties to write an equivalent expression that has no like terms and no parentheses. What are they saying here? To simplify expressions. Okay, this is what they mean simplifying. We can have 2 numbers, that is 3 plus 3. We can simplify that by writing as 2 times 3 because there's 2 of them. 1, 2. There's how many 3's are there? There's 2 of them. Okay, so 2 times 3. Or you can solve it and give me the one expression, one value. Same with x. How many x's do we have here? We have 2 of them, so we can write it as there are 2 x's. Okay, that's what they mean by simplifying. So here we have simplifying the expression. We have 4 6x's, right? 4 6x's. And you know that if we have 4 of them, what's the actual total? Well, we have 6x, 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 6x. How many x's do we really have in total then? If we have 6 here, plus 6 here, plus 6 here, plus 6 here, why not simplify this? So we write it 4 times 6x is really 4 times, or 4 6x, 4 times 6x. So I can simply use what we call the associative property. Remember, this one and this one work together, so we group them, we associate them, and we use associative property to put the 4 times 6 together, and then times x. 4 times 6 is 24, and we have our x there. So you can try these on your own. Pause the video and try it, or you can watch me do it. Okay, now let's see. I have 3 times x times 11. I'm going to use associative property and put my numbers together, right? 3 times 11 times x. Yes, 3 times 11 times x is 33x. Over here I have x plus x plus x. It's simply, there's 3 of them. There's 3 x's, right? 3 x's. And then I have 7x plus x. I'm going to use these like terms. Remember, this is 1x, right? So I have my 7x plus x plus 8. There, I use associative property. 7x plus x equals 8x plus 8. Now watch this. I can go even one step further, can't I? I know that I have 8 right here. I can stop there. This is my final answer, right? This is my final answer, but I just want to show you now in red. This is additional. You don't have to write this down. This is the common factor, and I can write x times x plus 1, right? Because 8 times x is 8x. 8 times 1 is 8. Okay, now we have to write an algebraic expression for a real-world scenario. 3 friends, you have 3 of them, will pay X amount of dollars each for admission to go in to a museum, plus $1 each to view the mummy exhibit. A 4th friend will pay the admission but will not view the mummy exhibit. Write and simplify an expression that represents the total cost. So we have 3 friends. Don't forget that. 3 friends first. So we can write our 3 friends. And they're each going to pay X amount. So it's multiplied by 3. You see that? Each is going to pay X amount we don't know. And they're each also going to pay $1. Right? They're each going to pay $1 for the exhibit. And, where is this? A 4th friend will pay the admission but not. So we have to add one more admission. You see, we added one more admission, but not $1 for the mummy exhibit. So we really have this expression right here. That's what we end up getting. But then we're being asked to simplify it. So how do we simplify this expression? Well, we look for like terms. 3x plus x in total is going to be 4x plus the 3. There we go. So the total cost is 4 people times x will give me the amount of dollars for admissions plus $3 to see the mummy exhibit. Okay, let's try this one together. Write and simplify an expression for the total cost of 6 friends to go to the museum if only 4 friends view the mummy exhibit. So 4 friends are doing both of them. 4 friends, I mean there's 6 friends going, right? But 4 friends are going to view the exhibit and pay for the admission. So I know that I have 4 friends. Let me do that in white, sorry. I have 4 friends that will pay the admission and the mummy exhibit. Am I right? But only, and then there's 2 friends left over because 6 friends are going in total, and there's 2 friends that will only pay the admission because 2 friends will not go see the exhibit. So plus 2x. In total, we have 6x. See, I have 4x and 6x. All friends of them, but only 4 of them are going to see the mummy museum. So I can solve this, and I have 4x plus 1. Oh, sorry. No, 4x and 4 plus 4 plus 2x. I found my like terms. 4x, 2x. I have 6x plus 4. Simplify expression with 2 variables. For example, what they're saying here is we have 3 plus 3 plus 4. Well, why not just say 2 times 3 plus 4? You see that? And we have x plus y. Well, how many x's do I have? I have 2 of them. Yes? 2 x's. So I just write 2 x's plus y plus y. And now we're going to start using the properties that we learned about in the previous lessons. Commutative property, okay, to change the order, and it doesn't affect the our product or our sum. And associative property, to associate them, to put them into groups, and then find and combine the like terms. So here we have, for example, we have 14y plus x plus 22y. Well, I know the 14y and the 22y will work together, so I can go ahead and manipulate it in a way. So you notice I'm shifting around the order, right, to put the x out and put the 14y and the 22y together side by side. Then I use the parentheses to group them, associative property. Then I work it out to 36y plus x. Okay, and then you can simplify it as well using distributive property. I have 4 times 2x and 4 times y, right? 4 times 2x, 4 times y equals 8x. 4 times 2x is 8x, and 4 times y equals 4y.